So, the vertex form of a quadratic is different from the regular standard form of a quadratic. It is the following equation. F of x equals a times x minus h quantity squared plus k. And you know that f of x is the same as y. Okay? Now, just like our standard form, how can we tell if that opens up or down? If the a value is positive, it opens upward, right? If the a value is negative, it opens downward. All right? Now, what about the axis of symmetry and the vertex? The axis of symmetry and the vertex. Let's pull away from that right now for a second. What other equation do we know of a shape from geometry that has the h and k in the equation? Anyone remember? Circle. A circle is like this. A circle is x minus h squared plus y minus k squared equals your radius squared. What do the h and k represent here? It's a coordinate. What coordinate? Well, it's a circle. It represents the center of the circle. Okay? This is the center of the circle. It's an actual coordinate. It'll give you an x and y coordinate. So what coordinate do you think, now we come back here, is h and k going to represent a parabola? It's the vertex. That's actually the vertex. So my vertex, which is a coordinate, is going to be h, comma, k. Now be very careful. All right? Be very careful here. Because your k value, whatever that is, just goes here.
I go on.
Right. This would be your x coordinate and your y coordinate of the vertex. But the h is negative. You're going to negate it when you put it into the equation, which means when you take it out to put it into your vertex, you also got to flip the sign. The positive h goes here in your vertex. This is a positive h. Okay? This is a negative h. All right? So just be aware that when you put it in the equation, whatever the sign is, you need to flip it. And just when you take it out, you also need to flip the sign. It doesn't mean that this h is always positive in the vertex. It means it's going to be the opposite sign of what it is in the equation. Okay? So now that we know the vertex, that's not bad. It's just h and k. How can we do the axis of symmetry without any work? That's always x equals, isn't it? It's that vertical line that reflects the parabola over itself, cuts it in half. And if we figure out what the axis of symmetry is first, isn't that always what? What value is this here? It would be, if I had the standard form, it would be negative b over 2a, absolutely. But this is the vertex form. Once we figured out, in their standard form, when we had x equals negative b over 2a, how did that help us with the vertex? That's the x value. So guess what you think the axis of symmetry is going to be over here? Whatever the x value is. It's also h. Right? The axis of symmetry is always the x value in the vertex. Well, what's the x value in the vertex? It's h. So that's what this is. You really have done no mathematical work here whatsoever up to this point. Now we're going to find the x-intercepts. We're going to do some algebra, but you know what? It's like 9th grade stuff. What is the difference between the vertex form, let me go back here, and something like this, here, which is a standard form? Take a look at that, how that's written, and take a look at this. Yeah, you said something that I really keyed on, it's where I'm going toward. You said the x's, which means there is more than one x here, isn't there, for the standard form? Which means I would have to, like, you know, cheekage and T-bone, or maybe use slip and slide, or maybe use the quadratic formula, right? B squared minus 4ac over 2a. This is review, we've done this already. I'd have to do these because there are more than one x here. And is there more than one x here? There's just one. So I can just solve for x. I can just solve for x. So it's actually easier to solve for x than factoring and solving. All right? If you wanted to, you could FOIL that out. You could put everything on the inside. Combine my a, distribute the a. I could do that and then factor, but that's a lot of work. I just solve for x. Okay? So, using algebra, let's describe the graph of the following. Y equals 3 times the quantity x plus 2 squared minus 1. How does this open? It opens up. And how do we know that? Yeah, because my a value, which is 3, is bigger than 0, or it's positive. It's positive, right? So we know it opens up. So it'll look like this. Forever should open up. Done. What about the axis of symmetry? What is that? So we have our h and our k, right? So I'm hearing that x equals 2. You guys agree?
Yeah.
There's one thing wrong with that. What is it?
Oh, yeah.
It's negative 2. Remember, the equation is technically y equals ax minus h squared plus k. If this is a positive 2, well, I got to subtract that. It's like subtracting a negative 2, isn't it? That's what makes it positive. So I'm subtracting a negative 2 to make it positive. So this is actually negative 2. Remember, that h value, you've got to flip the sign when you take it out, or flip the sign when you put it in the vertex. So if x is negative 2, what's my vertex? Yeah, I need an x and a y, right? Well, negative 2 from here. And what's my y value? Negative 1. The k we do not switch. The k we do not switch. That might trip up a few people. Now, let's find our x-intercepts. And all we're going to do is we're just going to solve for x. But before we do that, is this starting to look familiar, these answers here? Look at the one problem we did in standard form. Wasn't it a 3 and it was opened upward? Wasn't the axis of symmetry negative 2? Wasn't the vertex negative 2, negative 1? I think we should get the same answers. What were our x-intercepts for that? Before I even solve it this way from the vertex form.
It was
What is
6 plus or minus square root of 3.
All over 3. This is the problem we had in standard form, right?
Yeah.
Okay. Well, I'm starting to think this is the same problem. We should get that same answer. All right. Well, let's solve. Okay, x-intercepts are the roots. They're the zeros, right? Solutions. So if I set this equal to 0 and solve it, I should get my x-intercepts. 3 times x plus 2 squared minus 1. Since there's only one x there, I'm just going to start peeling away from it one at a time, right? What's the first thing I should get rid of there? Yeah, I'm going to add 1 to both sides. So when I do this, I've got 1 equals 3 times x plus 2 squared. What's the next thing I should get rid of?
3.
Yeah, the 3. It's reverse convex, right? I'm going to get rid of the 3. These cancel. Here we go. Yes, I definitely am going to leave it as a fraction. So I now have 1/3 equals x plus 2 squared. What should I get rid of next?
The square.
The square. What's the opposite of square?
Square root.
Square root. So I now know the square and the square root cancel. So I have x plus 2 equals. Let's clean this up. If I have radical 1/3, that's the same thing as saying radical 1 over radical 3, right? Mm-hmm. What is the square root of 1? It's 1. What's the square root, or excuse me, how do we get the square root out of the denominator? Yeah, I do. I multiply the top and bottom by radical 3, absolutely. So I multiply the bottom by radical 3 and the top by radical 3. So now I've got 1 times radical 3 is radical 3 over 3. Because this is radical 9, isn't it? Which is 3. So I have radical 3 over 3. What's one thing I'm missing?
Divided by 3.
Close. When I take a square root of both sides, what should I do?
I'll put the
Plus or minus. Okay? So, this is what we have right here. I'll move that. Is it starting to look a little bit like this answer? It is. I mean, we got the plus or minus radical 3 over 3. So now we just got to do what to get the x alone? Subtract 2. If I subtract 2 from both sides, I've got negative 2 plus or minus radical 3 over 3 equals x. That would be an acceptable answer. In fact, if you're going to know how to simplify this right here, I would say negative 2 plus or minus the square root of 1/3 would be an acceptable answer. But if they ask you in simplest form, you're going to have to simplify that. Or if it's multiple choice, I'm going to show you. It'll probably look like it was multiple choice, like this right here. And how can we get our current answer to look like that? Let me show you. If I'm adding or subtracting, and I have 2 fractions, this is secondly over 1, isn't it? Don't I got to get the bottoms to be the same? Yeah, so I'm going to multiply this by 3, and what do I do to the bottom? I have to do the top. So what do I have here now? Plus or minus radical 3 over 3. Guess what? When I combine them, add or subtract, does the bottom change?
No.
No. That is the exact same thing that we have right here. Exact same thing. It is the exact same answer, same problem. So based on all those answers, the standard form that we solved all that for, and the vertex form, it's the same problem. Let me show you how it's the same problem. All right? I'm going to factor a 3 out of here. If I say y equals 3 times x squared plus 4x plus 11. Someone in my other class said, can't you factor an x out of there? I could, but remember, I want to try and end up with something like this, where I have a quadratic in here. Because x plus 2 squared is a quadratic, if I FOIL that out. So I want an x squared plus 4x. Now, do you guys remember completing the square? How do I make this a perfect square? I've got to take my b value. The b value is the one in front of the x, right? I got to take my b value, I got to cut it in half, and then I square it. So if my b value is 4, and I cut that in half, and square it, what's 2 squared? So if I add 4 to this parenthesis, it will become a perfect square. But I can't just add 4 to the y, that would screw things up. So how do I keep that the same? Well, if I add 4, I'll just subtract 4 too. Meaning, if I had the number 5 and I added 1 and subtracted 1, isn't it still 5? It is. So I'm going to do that same thing here. I'm going to say y now equals 3 times, and I'm going to put a square bracket there. It's x squared plus 4x plus 4. That is now a perfect square, but I also put minus 4, so it's the same. Plus 11. Okay? So what did I do? I factored out the 3, which kept it the same, because if I multiply it back in, it's the same thing. I added 4 and subtracted 4, which is like adding 0. Still the same. So now, I'm going to distribute this 3 to everything in square brackets. In front of here, and to that. Okay? So y equals 3 times x squared plus 4x plus 4 minus 3 times 4 is 12 plus 11. All right? What's one thing I can combine that you see right away?
Negative 12 and 11. Negative 1.
These combine to give you a negative 1. I still have my 3 out front, and what can I do with this? If I factor that, if I take x squared plus 4x plus 4, find two numbers that multiply to 4 that add to 4. What are they? X plus 2 times x plus 2. And if I multiply anything by itself, like 5 times 5, isn't that 5 squared? So if I multiply x plus 2 times x plus 2, is that x plus 2 squared? It sure is, people. It is the same exact thing. That is why we got the same answers. We should. It's the same parabola. If I were to graph the standard form and that in the calculator and y1 and y2, it would be the same thing. Here we go. Now, you will see something like this in your homework. All right? Let's write an equation for the following parabola given 2 points. When you think parabola, you think the standard form. Ax squared plus bx plus c. But if we think of the vertex form, y equals a times x minus h squared plus k, and we have 2 points, that is going to make life so much easier. Now, I said we always need a y, and we always need an x in our equation. So, yeah, wait. We're going to get right there. We are going to get right there, absolutely. But I need these 3 letters. Where do you think I can get? Can I get any of them? Can I get one of them? Can I get 2 of them?
A and A.
Where would I get the A? Not the A.
Oh, no, you can get an H because the H is the X value, right?
Yeah, of the vertex, isn't it?
Yes.
And what's the K value?
The K value is the Y.
Y in the vertex. So this right here gives us our H and our K. Right there. We did not have to do any math. It is listed right there for us. So, my H, I subtract a positive 2, right? So remember, when I put that in, I gotta flip the sign, so it's like subtracting 2. Minus 2. I don't want to put a plus 2 here. It's minus my H value. Plus, what's my K value here? So I can say plus a negative 7, or if this was multiple choice, they would just say minus 7. They would just say minus 7. Okay? That's all fine and dandy, but now this A, where do I get that? Now, if I had a value for x and y, I would have numbers for everything except A, and I can just solve for A. Where do I get them from? So that's where the second coordinate's for. This is an x, and this is a y. So guess what? My y, if I use this coordinate, so my y is 5 equals A times my x is 0, and I'm just getting them from here. Minus 2, I square that quantity, subtract 7. I just solve for A. And I have all 3 letters. I have my A, my H, my K, and I plug them in. Well, yeah, I would square, yeah, you could do that. I would just square, what is this value right here? Negative 2 squared. It's positive 4 times A, right? This is going to be 4A minus 7 equals 5. And now, yes, I would add 7. If I add 7, what is 5 and 7? 12. So 12 equals 4A. 4A equals 3. You got it. So A equals 3. Here's my A. Here's my H and my K.
So Y equals X and Y.
Yeah, so hold on. Well, for the equation, we always want to keep an X and a Y in there.
Alright, so Y equals 3.
Y equals
X minus.
Wait, I got a question.
Squared and minus 7. Question.
So, 0 minus 2 is negative 2. But negative 2 squared is that's 4, right?
It is. It is. No, you're right. Absolutely right. Absolutely right. That's why I say in the calculator, if you put this in the calculator, you'll get 4. If you do this in the calculator without quantities, you'll get negative 4 and it'll be wrong. Because you want to square the negative with it. That's why you want to do this. The calculator, if it goes according to PEMDAS, will square the 2 first, then apply the negative after. Okay, so in your calculator, it's really crucial that if you're going to square a negative number, you include the negative with the number when you square it. And keep the square outside. If I do this, I'll still get the same thing. I'll square the 2 first, and then apply the negative. You want to put your square on the outside. Okay? Very good.
Bam.